So this is question 27 from cohort topic 3 on probability. I'll read the question carefully just to model good habits when you're on a test. Suppose a basketball team had a season of games with the following characteristic. 60% of all the games were at home. We're going to use an H for that. Away games is the name for not H. 40% of all games were wins. That's going to be a W, and losses is the language we're going to use for not W. And 35% of all games were at-home wins. That means they were H and W. They were both. So part of my brain is thinking about Venn diagrams immediately because I've got home games, I've got winning games, I've got a certain amount that are both. That's a pretty classic Venn diagram scenario where there's two characteristics of one thing and there's some overlap and some non-overlap. I might need it. I might use that, but I also might not need the Venn diagram. Let's continue reading the question. Let's go on to read the question and find out what the strategies will be. Of the at-home games, what proportions of games were wins? All right, so we finally have a question. Of the at-home games, what proportion of games were wins? So this sounds like it's certainly asking me a probability question. No surprise, topic 3, probability. What proportion of games were wins? So that it's looking for wins. That's the question. The decimal or percentage wins. But it's not just, 60 it's not just that 40 of all games. It starts with of the at-home games. Of the at-home games. That's another way of saying, given it's an at-home game, what's the probability there was a win, right? So that's, if I want to use the, pardon my slightly scratchy handwriting, basically we can translate this as given a home game, you're being asked for the probability of W. But, we have a name for given probabilities given a condition, right? This is simply the probability of the W, probability of a win, given that it's a home game. Remember, we kind of want to remember if you just looked over here, right, stopped with the parentheses there, then you would see probability of W. What's the chance of a win? But then, of course, you have to move on and go, oh, probability of a win, vertical line says given that it's a home game. There's a formula for this. You probably should know it. By knowing it, I usually mean understand it, not just memorize it. But it's enough to have it memorized. The probability of the conditional probability is simply the probability of the intersection. So we need W intersect H on top. And remember, our condition, our given is it's a home game. So of course we can't find the proportion of win and home out of everything. We need the proportion of win and home out of home games, right? Home games are not everything, but we're under the condition. We know it's a home game. What's the chance that it was a win? And it looks like we can compute this without actually going to Venn diagrams, right? Win intersect, W intersect H, that's win and home, right? That's the at-home wins. So that's a 35%. Remember, that's 35% of everything. But that 35%, given that it's a win, right? Right. Sorry. Sorry about that. Given that it's at home, right? The condition is the at home. So 60% of all games. So the 35% is compared to the 60% before we decide on what the final answer is, right? For that, we need to whip out the calculator and figure out what 35 over 60 is. It'll take me a moment. I don't really care that much, except the multiple choice answer, you know, might be, you know, you never can tell. Uh, it might be in decimal form, might be in fraction form, might be this fraction reduced by factoring the fives out. Anyway, the answer in decimal form is 0.5833, and generally we're gonna, we're probably gonna have integer or maybe one decimal of accuracy in our percentages. And it asks for a proportion. I can answer in a percentage. Proportions and percentages are fairly interchangeable. If all the answers were decimals, I'd go for 0.583, right? That's not the big deal. The big deal is realizing it's the 35 out of 60, not 35 out of 100, the usual percent. But the condition was home, so there's only 60. That's kind of it. Conditional probability feels challenging, but it's really about the language. Read it carefully and simply ask yourself, what's the question and what's the condition, the given? By the way, I have my own little trick for translating this. I think the top for a conditional probability, I always immediately figure out the intersection, right? If I'm talking about, I know it's a home game, I don't care about wins that aren't home games. So I've got to look at all the games that are win and at home. And of course, that gives me a small portion of the whole. It's an intersection, so it got smaller. But I'm not interested in the whole Venn diagram, the whole 100%. I know that I only care about home games. So I have to take that intersection of the thing I'm looking for and the condition and divide by the condition. Right? There's only two things going on, the condition and the event that you're wondering about the probability. So it's the intersection of the event with the condition divided by the condition. Intersection over condition. That's what I try to get students to repeat, to think of, to appreciate when they're doing conditional probability. It's really just the probability of something happening in a smaller universe, not the whole universal set of 100%, but the smaller one. In this case, your 35% is out of the whole, but that 35% was given its home. So it's only the smaller 60% that the 35% needs to be compared to. It's a rather larger proportion of 60 than it is of 100. Let's go on to the other one. If the team won a game, it is given they won a game. That's the condition. How likely is it, right, that this was a home game, right? That's the question. The question is, what's the probability of the event of home game? They're asking about probability of home, and the condition is 1. So there's the event, and there's the condition. Or I could say given, condition, given. And once I know that, well, once you've identified those things, then it's just a ritual of numbers and symbols, right? This question is actually asking, what is the probability that we had a home game given that we won? And as always, a conditional probability is the probability of the intersection divided by the probability of the condition. And in this case, the team won. So that's the condition. Sorry about that weird line. The intersection, H intersect W, that's still the 35. But now we're thinking about the 35% in relation to only the 40% of games that were wins. That's a larger proportion. Again, pull out your calculator and, as a decimal or a percentage or a fraction, whatever the case may be in your multiple choice, this actually comes out to 87.5%. Now let's be very clear here. You have to read carefully because it's very easy to swap the bottom, right? 60 versus 40, same 35 on top, right? If these were multiple choice, then both of them would, one would have, there would be 58.3 as well as 87.5 because one of the common errors is to swap, not do the condition on the bottom, do something different, something stranger. Another clear distractor would be just 35%. That's not conditional probability. That's just the probability of both happening, right? Both happening. Not if I know one thing happens, then what's the chance of the other? The intersection is just what's the chance of this and that happening simultaneously. So 35 is an answer. The wrong fraction is an answer. And I can't really think of any other good distractors. I just want to warn you, be very careful. You keep track of the condition or you'll wind up with the wrong fraction. And be very careful you don't just answer the intersection when you're being asked a conditional probability. I hope you found this helpful.